Hello everyone and welcome to this tutorial on frequency polygons. Now in mathematics there's lots of different displays of data. Some examples are pie charts, bar charts, composite bar charts, line graphs, cumulative frequency curves, histograms, scatter diagrams, Venn diagrams, box plots, pictograms and frequency polygons. There are so many different types depending upon what data you have, where some graphs are more appropriate displays than others. In this tutorial, we'll be looking at frequency polygons. So what is a frequency polygon? Well, a frequency polygon is used to display grouped data. It's important that you remember that we plot the midpoint against the frequency, and we always connect using straight lines. Frequency polygons can also be combined with identifying the modal class, in other words, the class with the highest frequency, or paired with calculating the estimate mean. And remember, to work out the estimate mean, it's sigma fx over sigma f. So knowing this, let's have a look at some past exam questions. This question gives us a table showing information about the weights of 50 potatoes. We know there are 6 potatoes between 10 and 20 grams, including 20 grams, but not including 10 grams. We know there's 21 potatoes between 20 and 30 grams, including 30 grams, but not including 20 grams, so on and so forth. I better drew this frequency polygon for the information in the table. Now we know the frequency polygon is not fully correct, and the question asks us to write down 2 things that are wrong with the frequency polygon. There are quite a few things wrong with this frequency polygon. Firstly, you can see there's no frequency labelled in the y-axis. This is very important given our definition and key points that we looked at before. We also know that the frequency polygon can't be closed. Lastly, we always plot the midpoint against the frequency. And if we were to look at this point here, you can see the midpoint between 10 and 20 is 15. With a frequency of 6, but this has been incorrectly plotted. So it's really important that you look at your axes when plotting a frequency polygon. So the 2 points I'm going to pick up on are the frequency is not labelled on the y-axis, and the first and last points should not be connected. Now looking at our next exam question, the table shows the information about the heights of 60 trees. We know there's 13 trees between the height of 0 and 4 meters, including 4 meters but not including 0 meters. 24 trees between the height of 4 and 8 meters, including 8 meters but not including 4 meters, so on and so forth. Jacob drew this frequency polygon for the information in the table. The frequency polygon is not correct, and we're asked to write down 2 things that are wrong with the frequency polygon. See if you can give it a go and press pause if you need. So hopefully you spotted the 2 main things wrong with this question. First things first, points should be connected using straight lines. This was our key information that we discussed at the start of the lesson. The second point is that the midpoint needed to be plotted against the frequency. Here, between 0 and 4, the midpoint is 2, but Jacob plotted 4. Here, the midpoint should have been 6, but Jacob plotted 8. So the 2 mistakes were Jacob should have connected using straight lines, and Jacob needed to plot the midpoint against the frequency. The next exam question states that Helen went on 35 flights in a hot air balloon last year. The table gives some information about the length of time of each flight. We're asked to draw a frequency polygon for the information. Now remember our 2 points. It's important that you plot the midpoint against the frequency, and we connect using straight lines. So let's find the midpoint between 0 and 10 minutes. A nice little way is to sum the lowest and highest class values and divide by 2, which is 5 minutes. So plotting our 5 minutes with our frequency of 6 gives me my point here. The next midpoint is 15 minutes, plotted against a frequency of 9, which gives me my point here. The next midpoint would give me 25 minutes, plotted against the frequency of 8, which gives me my point here. The next midpoint would be 35 minutes, plotted against a frequency of 7, gives me my point here. And the final midpoint would be 45 minutes, plotted against a frequency of 5, gives me my point here. Remember to connect using straight lines. Let's have a look at another exam question. Here we have a table which shows the information about the heights in centimetres of 30 sunflowers. We're asked to draw a frequency polygon using this information and also identify the modal class interval. See if you can give it a go and press pause if you need. Remember our 2 points when we're drawing a frequency polygon. Always plot the midpoint against the frequency and connect using straight lines. So let's find the midpoint between the heights of 100 centimetres and 120. Well, remember the nice little trick. Sum the lowest and the highest class values and divide by 2. So we plot 110 centimetres with a frequency of 2, which gives me my point here. The next midpoint would be 130 centimetres plotted against a frequency of 6, which gives me my point here. The next midpoint would be 150 centimetres plotted against a frequency of 7, which gives me my point here. The next midpoint would be 170 plotted against a frequency of 12, which gives me my point here. And lastly, the next midpoint would be 190 centimetres plotted against a frequency of 3, which gives me my point here. Connecting using straight lines gives me my final frequency polygon. Now part B asks us to identify the modal class interval. Remember, the modal class is the class with the highest frequency. So it must be 160 centimetres less than h, which is less than or equal to 180 centimetres, because this is the class with the highest frequency. So let's have a look at our last exam question. Here we're given a table of information about the temperature in degrees at noon in a town for 50 days. And we're asked to calculate an estimate for the mean temperature, as well as to draw a frequency polygon for the information in the table. See if you can give it a go and press pause if you need. So remember, to calculate the estimate mean, it's sigma fx over sigma f. So we're going to have to extend our table and calculate the midpoint, which we know to be x. And from here, then we can identify fx. Well, firstly, we know x to be 10, because it's the midpoint of 8 and 12. The midpoint of 12 and 16 is 14. The midpoint of 16 and 20 is 18. The midpoint of 20 to 24 is 22. And the midpoint of 24 to 28 is 26. fx means the frequency times our midpoint. So multiplying gives us 60, 112, 234, 462 and 52. Now sigma fx means we need to sum all the values of fx, giving us 920. Sigma f means we need to sum all the values of the frequency, which gives me 50. So, to work out the estimate mean, it's simply 920 divided by 50 to give me the estimate mean being 18.4 degrees. Now we know our estimate mean, let's draw our frequency polygon. The great thing is we've identified the midpoint because we worked out x. So now we simply need to plot. Now with this question, it's really important you pay careful attention to the axes in this question, because 2 squares represent 1 unit vertically. So let's plot. Well, we know we have a midpoint of 10 with a frequency of 6. We have a midpoint of 14 with a frequency of 8. We have a midpoint of 18 with a frequency of 13. And we have a midpoint of 22 with a frequency of 21. And a midpoint of 26 with a frequency of 2. Connecting using straight lines, we have our frequency polygon. So in summary, remember a frequency polygon is used to display grouped data. We have to identify the midpoint and plot it against the frequency. And always remember to connect using straight lines. Frequency polygon questions can also be paired with data analysis, such as identifying the modal class or working out the estimate mean.
If you liked this video, please give us a thumbs up. Leave your comments down below and subscribe to this channel so you'll be the first to know when we release our next video.